So welcome everybody to another session of Lógicos in Quarentena. I would like to thank you very much, Professor Bruno Bentzen, who kindly accepted our invitation to give this talk. Bruno, thank you very much.
Thank you, Bruno, and also thank you, Bertuccio. It's a pleasure to be here, and well, I thank you for the invitation. And I want to also give you a special thanks for organizing this webinar series, because it's a very nice way of keeping the community together in those difficult times. So it's an honor to be here. So one problem of giving a talk with a question title is that people usually expect you to give you a reasonable answer to it. And I'm not sure if I'll be able to do that, but I'll give my best so that you can leave this virtual room with something. So let me just, okay. So this talk is based on a project I've been working on since June of last year. And I already have written something about it. And if you're curious, you can just go check it. And if you have any comments or suggestions or criticism, feel free to email me, or you can just ask me now or after the talk's. Anyways, so this talk's going to be split into 3 main sections. And in the first one, I'll give you a basic overview of symbol type theory, which is the kind of type theory that I'll be based on. And I'll also give a brief overview of Frege's formal system, the formal system of Grundgesetze. And also I'll try to answer the question, the title of this talk, at least give a preliminary answer to it. Then the remainder of this talk is based on 2 type theoretic interpretations of the formal theory of Grundgesetze. Actually, those interpretations are interpretations of Frege's theory of functions. One of them will be based on the idea that Frege's functions are closed terms of a function type, and the other one will be based on a different idea, the idea that Frege's functions are open terms in the hypothetical judgment. And I'll conclude by saying that none of them really accommodate Frege's conception of function. So let's get started. And before I can say anything, really, I have to say a few words about what type theory really is. And this is a really rough definition, because it's hard to give a really formal definition of what type theory is, because the field is always in development, in active development. So type theory can be, you can think of it as a class of formal systems where every term has a type, and operations are restricted to terms of a certain type. So if you have arithmetic addition, for example, well, this operation is restricted to terms that are of the type natural number. And this idea has long historical roots, but most notably, it can be attributed to Russell's doctrine of types that has its origins in 1903. And another thing that can be useful for this talk is a distinction between judgments and propositions. So judgments are the things that the rules of inference operate on, and the propositions are the things that logical connectives connect or operate on. And this distinction is not very common in logic textbooks if you open them, because in most presentations of deduction systems, such as natural deduction, you will see that rules of inference usually the premises they look like propositions, and the conclusion they look like propositions. But actually, what we have here is a rule that go from judgment to another one, such as in conjunction elimination, for example, you have A and B, and the conclusion can be A, for example. So you have a rule that goes from the judgment A and B is true to conclusion A is true. So a proposition can be described as the content of a judgment, if you will. But it wasn't always like this. And in the early days of logic, since Aristotle, the traditional form of judgment was the subject-predicate copula, where you have a subject and you predicate something of it. And this traditional view, it was abandoned, especially since Frege's rigor shift. But somehow type theory has a form of judgment, a basic form of judgment that looks like it structurally, at least. So you have, on the one hand, you have a term, and on the other hand, you have a type. And you also, when you want to say something about a term, you also have to say it in the context of its type. So there's no way to speak of a term or of a type in isolation. You can only speak of a term in a type. And there are other forms of judgment in type theory, but this is the only one that I'll be considering this talk, or at least the basic one that I'll be considering. So judgments, they can be made categorically, which means that when you make or assert a judgment, you are not assuming any hypothesis. Or they can be made in the context of a hypothetical judgment, which means that when you make such a judgment, you are assuming certain typed variables. And there's another distinction here between closed and open terms. So a closed term is a term that doesn't depend on free variables. And well, a similar definition for dual definition for open terms. So I'll be here mainly concerned with simple type theory in the sense of church. So here you have on the top a rule that can be described as an axiom. So if you assume that X has type sigma, well, it has type sigma. And going from the rules that follow it immediately, the two rules, you have on the left a rule that says that if you have a function from sigma to tau, and you have a type of term sigma, then you have a term or an element of type tau. And another rule that says that if you assume that X has type sigma, and you can derive that F has type tau, then, well, you have a function from sigma to tau. And if you know something about Curry's-Howard isomorphism here, you probably already noticed that those rules, they look like the implication and the implication, introduction, and elimination in natural deduction. And the remainder rule, it's really just a computation rule that essentially formalizes the fact that there are no detours. So I am really not alone when I say that much of a theory of types is anticipated in Frege's Grundgesetze. You have some beautiful expositions of the idea in, for example, a book by Kamerdine, Lan, and Ederpelt, and also another exposition in Ernst Clav's dissertation. And so the idea is that Grundgesetze was the foremost theory that Frege developed to vindicate his logicist program. And the program says that, well, the aim of the program is to establish the fact that all arithmetical concepts are definable by purely logical means, and that all arithmetical theorems are derivable from logical laws alone. So when developing his formal system, Frege is based on a distinction that is very sharp. So that's the distinction between objects and functions on the ontological side, and object and function terms on the syntactic side. So in the formal system of Grundgesetze, and well, for the sake of conciseness, I'll refer to it as the ideography. Another term would be the concept script, but I don't think this will love the tongue that well, so I'll be using ideography. So in ideography, object terms there are described as saturated and complete terms, and function terms, on the other hand, there are unsaturated and in need of completion. So that means that Frege's system is always implicitly operating on type terms, because given a well-formed term, it will always be an object term or a function term. There is no way it can be any other thing. So this dichotomy, it is clear in, for example, section 2 of the first volume of Grundgesetze, when Frege says that objects stand opposed to functions. Accordingly, I count as an object everything that is not a function, e.g., numbers, truth values, and the value ranges introduced below. Thus, names of objects, the proper names, do not in themselves carry argument places. Like the object themselves, they are saturated. So type theoretically, you can think of Frege's geography as a system that has two basic types. One, a ground type of individuals that I'll denote with the iota, and a function type. I use the arrow for this type. And here in this context, uniqueness of type, it just means that every term, every well-formed term, will either refer to an object or to a function. So Frege has 8 privative function signs, and 5 of them are first-level functions. So you have here the horizontal, negation, implication, identity, and definite article. And he has 2 second-level functions, 2 primitive second-level functions. And those are the first-level quantification and the abstraction operator that operates on a function to result in a value range. And then he has only one primitive third-level function. At least he only considers one in the book, which is the second-level quantification. So by level, Frege here means that a first-level function is a function that operates on, that takes object as arguments. Second-level function takes first-level functions as arguments. Third-level function takes second-level functions as arguments. So in here you can see that Frege uses different argument letters for them, for each one of them. So here again you have implicit type conventions. And besides those implicit type conventions that I already mentioned, in the context of functions, Frege uses many others. So he has a distinction between Roman, Greek, and Gothic letters. And each one of them has a kind of range of letters. For example, Roman object letters, he uses letters from A to E typically, or I to L, or N to Z, things like that. I'll have some things to say about Roman, Greek, and Gothic letters soon. But for now, what is important is to note that the type of an operation, it depends on its level and also on its number of arguments. So following Quine, we may say that Frege has a hierarchy of types. So first, we have objects of the type of individuals, or level 0. And then you have first-level functions. And then you have second-level functions and third-level functions. Frege doesn't really have higher functions because he doesn't need to, since value ranges for him are objects. So he doesn't have to consider all like an infinite hierarchy of functions, because those are enough. And it's easy to see here that given this characterization of functions, the self-application, the explicit self-application F applied to F will always be ill-typed, right? Because there's no way you can do that. Since functions, they always restrict. They are the kind of arguments, the range of arguments that it takes. And this is actually Frege's response to Russell's fateful letter, the letter that communicated him of the contradiction. So Frege here says that, incidentally, it seems to me that the expression a predicate is predicated of itself is not exact. A predicate is as a rule a first-level function, and this function requires an object as argument and cannot have itself as argument, subject. Therefore, I would prefer to say a notion is predicated of its own extension. So basically what Frege is here saying is that, look, I actually closed the front door of my system, but I forgot the back door open. So what he's saying is that, well, it can't predicate a predicate by itself, but since extensions of concepts, which it's an idea that is defined in terms of value ranges of functions, because for Frege, a concept is a function that has true values as values. And the idea that since value ranges, they are always objects, given any function, the value range of that function would be an object. You can apply the value range of its function to itself. And so you have a certain kind of circularity in Frege's system. So already at this point, we can at least have a reasonable answer for the question in the title of this talk. So what went wrong with Frege's theory of types? Well, you can say that obviously that's what the problem is in Frege's doctrine, that value ranges of objects. And well, that's not a very interesting answer because, well, not in the sense that it's already been well explored in literature, and many people already have written about it. So maybe a more interesting question would be, why didn't Frege just abandon this thesis? And again, this topic is already well explored in literature. So there are actually a number of reasons why Frege didn't do that. So for example, he, in section 10 of the first volume of Grundgesetze, he has a transortal identification between truth values and value ranges. Actually, it's not really an identification, it's a reduction, because he says that truth values are reducible. Basically, they're identical to value ranges. So he reduces the two categories of logical objects in his domain to just one, that of value ranges. So if value ranges are functions, then this would be a category mistake, because for Frege, you can never speak of an object and an identity between an object and a function. That would be a category mistake. And then another problem is that the domain of logical object would be finite. It would be reduced to only two objects, because, well, if value ranges are not functions, then you can't have this identification. So the domain of logical objects only consists of the true and the false. And that would be a problem for Frege's definition of numbers, for example, because you would not have an infinite supply of logical objects. And that's one of the purpose of his theory of value ranges, because he will never run out of logical objects. So his concept of number will, that is defined in terms of value ranges in section 42 of the first volume of the Grundgesetze, will have to be reformulated. And also his conception of identity as a first level relation will have to be reformulated, because he could not speak of the identity between value ranges of functions. And since he could not do that, he would also have to reformulate basic law 5, which is a law that says that if two value ranges of two functions are the same, then they're coextensional and vice versa. So there are many reasons why Frege couldn't do that, at least given his own philosophy. So what I want to do here is to try to explore this answer a little bit. Well, obviously there's no denying that the problem is in Frege's doctrine that value ranges are objects. But I think that this doctrine is most of all a manifestation of a syntactic account of typing. And due to his syntactical account of typing, he failed to keep closed terms and object terms apart. And in the same way, he failed to distinguish between open terms and functional terms. So now let me proceed to the second part of this talk. So in the Begriffsprodukt already, you see that Frege formulates the turnstile judgment, which is essentially the kind of judgment that we now use in modern logic. Did I hear something? Okay.
Speak Portuguese?
Yes, please.
Is that a question or?
Yeah, there's a question.
Okay.
From.
Oh, sorry, I can't see anything here. I can only see my slides. Do you wanna?
Luis,
do you wanna
would like to
ask the question now, or maybe I should read it?
You speak Portuguese?
I speak Portuguese. Yeah, you can ask the question.
You is Brazilian?
Mm-hmm.
Oh, right.
Okay. I'm assuming I can proceed.
Yes.
So where I was, okay. So here we have a turnstile judgment. It's a judgment that says that a proposition is true, basically. So Frege has a different notation. He's a turnstile, but that's what it is. And this judgment in Begriffsschrift, it also comes with another implicit kind of judgment, which is the content stroke. Because in Begriffsschrift, a content stroke, it characterizes a preposition as the content of a turnstile judgment. So basically, it says that a vertical stroke or horizontal A, it means that A is a preposition. And when you have the vertical stroke, then this is something that confers assertive force to a judgment. So one thing is to consider the fact that A is a preposition, and another thing is to really assert A. So that's a really important distinction in Frege's Begriffsschrift. So more precisely, a preposition is just a judgeable content. So here's what Frege says about it. Not every content becomes a judgment when the turnstile is written before it's signed. For example, the idea house does not. We therefore distinguish contents that can become a judgment from those that cannot. And this idea can be, as I said, can be seen as a judgment. But later on in Grundgesetze, Frege actually abandoned this idea. So in Grundgesetze, there is really no judgment that you can use to say that A is a preposition. The only way to do that is to say that, well, A is a sentence that expresses a thought or has a sense, because a thought is just a preposition. But there is really no judgment that says that, well, A expresses a thought. There's no way we can do that. And given this this change, this modification to the ideography, the turnstile judgment also changed. Its meaning now is that if you have turnstile A, then that means that A is a sentence that refers to the truth. So here, for example, you have turnstile if A, then if B, then A. And well, you may ask yourself, well, what are A and B here? Because, well, given Frege's logic, well, implication has to operate on objects because truth values are objects, right? So are A and B object terms or function terms? Well, the obvious answer is that they have to be object terms, but this is not explicit in Frege's logic. So one type theoretical approach to it would be to just write in modern notation. You just use the type column notation to really make explicit the fact that A and B are object terms. And this would be my interpretation of Roman letters. So they will be interpreted as hypothetical judgments. And I want to say another thing about it is that
I don't speak English. Could you speak in Portuguese, please?
So another thing here is that I'll be treating this relation A column sigma as a judgment, and I'll also treat this predicate A true as a form of judgment. So to give an example, here is a one example that Frege uses in section 17, I guess. So it has this implication here where X is a Roman object letter. And here I would just write it like this. So I would just make explicit the fact that it's object letter. So already at this point, we can see that there's an interesting phenomenon here. On one hand, functions are unsaturated expressions, but on the other hand, not every unsaturated expression is a function term. So let me explain this. The reason is because sentences that have object, Roman object or function letters, they are not considered as referential sentences in Frege's ideography. So Frege says that I shall call names only those signs or combination of signs that refer to something. Roman letters and combination of signs in which those occur are thus not names, as they merely indicate. A combination of signs which contains Roman letters and which always results in a proper name whenever Roman letter is replaced by a name, I would call a Roman object marker. So Roman markers are sentences that have occurrences of Roman object or function letters. So those are Roman markers. So Roman markers here, they are just open terms in the type theoretic terminology. And they're not function terms because first, Frege does not accept them as referential terms. And well, in the language of Grundgesetze, every term, every functional expression has to refer to something, otherwise it's not a function. And another very important thing is that Roman markers, they are intended to represent generality. So Roman letters, they are just implicit quantification, so to speak. I'll have more to say about this later. So one question that we may ask is that, well, since function terms and Roman markers, they are just unsaturated in some way. Like if you look at them, they just look the same, except for the fact that Frege uses Roman letters for Roman markers, and he uses lowercase Greek letters for function terms, at least for first level function terms. You may say, well, why is that we have a difference here? I mean, why is one referential and the other one is not referential? And there is really no argument in Grundgesetze, at least not one that I could find, not one that says that, oh, here's why function terms, they are referential, but Roman markers are not. So one interesting thing is that in Frege's proof of referentiality, a proof that Frege gives in sections 29 to 31 in the first volume of Grundgesetze, to show that every name in his system is referential. In his proof, he establishes a few criteria of referentiality, and the criterion for functions is really interesting. It's given for unary and binary functions because Frege doesn't have functions of other arities, but he says that for a unary function, such as f of x, he says that this function is referential if f delta is referential for every referential object term delta. And a similar idea goes for binary, his characterization of binary functions. So instead of referential, we could say that they are closed terms in this type theoretical sense that I'm developing here. And an interesting similarity is found in Martin Love's mini explanations of 1982. So Martin Love's mini explanations of type theory for hypothetical judgments or for open terms is very similar in this regard. So if you have a hypothetical judgment, if you say that A is of type sigma, assuming that xy is of type sigma 1 and xn is of type sigma n, for example, then what is the meaning of this? Well, the meaning of this is that this judgment is evident if for all closed terms A1 of type sigma 1 and so on, then you have that their substitution is the case. So you reduce a hypothetical judgment to a categorical one that is true in every case. And this is basically what is going on here in Frege's criterion of referentiality. So already at this point, you see that there is an interesting similarity between function terms and open terms. Function terms in Frege sense, and open terms in the sense of modern type theory. So I already covered lowercase Greek letters in my previous slides, right? Because just remember that the argument letters used in Frege's functions, they are lowercase Greek letters. And also, there is another usage of lowercase Greek letters that is also important, and that is in his formulation of value ranges, because those lowercase Greek letters are the letters that are used as with binders on them. So now we talk about uppercase Greek letters, because they're important as well. And they're basically stand-in for referential terms, at least according to an interpretation by Hack that we're using here. That says that they are, those uppercase Greek letters, they serve as auxiliary names. So they're names that you add to the language to assume that they refer to something. So they are basically, they are a certain kind of, it's like an apparatus that it's somehow similar to the same purpose that you use when you assume that a variable like has a denotation or something in a more Tarskian sense. So the use of those auxiliary names, they're crucial to Frege's proof of referentiality already. So if you remember those criterions of referentiality here, they are just used, they're just stated in terms of uppercase Greek letters, which is one thing that makes sure that they are referential. So what would be the type theoretic equivalent of them? I think that the only alternative here is to view them as closed term. So you assume that this letter is a closed term, which means that it is referential. So therefore, if I have a turnstile judgment like this, consisting of just Greek letters, I'll be interpreting them as a derivation of a categorical judgment, assuming that you have a derivation that, well, that term is well typed. And now let me just go over Gothic letters real quick, because there's really not much to say about them, at least not for this talk. And I said that Gothic, that Roman markers, they somehow have implicit quantifications in them. And that's because in Grundgesetze, whenever you have a Roman marker, you can derive or can assume or can conclude that you have a quantification. So if you have fx, for example, then you can have a quantifier from it, and you can conclude that you have a quantified sentence, universally quantified sentence. So I can actually dispense with them entirely, because type theoretically, you can just use a column to make sure that they have the appropriate type. So Frege, he uses A for objects, or sometimes E, and he uses F for functions, but I will not follow this this convention. So now we have really two interpretation of functions, and I've already been talking about the first one, the interpretation of functions as closed terms. That's the interpretation I've been assuming so far. So Frege's doctrine of value ranges of objects can be type theoretically described as a rule that goes from function to a value range that is an object, where here this gamma is a context. This context gamma is just a list of typed Roman letters, right? So here it's easy to see that the problem with Frege's doctrine of value ranges as objects, the reason why the back door was open is because, well, they're objects. So I've been considering ways of alternatives to this this view, and I already can state that, well, there's at least one alternative that it's useless for us, and that will be the idea that value ranges can just be functions, in the sense that, well, if you have a function, then its value range is also a function, in the sense of this rule of inference here. Well, that would not make much sense. I mean, you could add that to your system, but it doesn't seem to serve for anything, because, well, you're not gaining anything. And I think it wasn't until church that we really realized how to make sense of the idea of abstraction. So instead of abstracting functions to make them become objects as value ranges, the idea is that you have to abstract an open term for it to become a closed term of a function type. So that's, I think that's an interesting turn here. It's like a paradigm shift in a sense. So if I were to follow church notation, then I'll just write this value ranges with a lambda term. So there are two interesting turning points in church theory of abstraction here. The first one is that, as I said, function terms.
Sorry, can I ask a question?
Sure.
On your previous slide, you said you're using Church's lambda notation for just the function, but
yes,
the whole thing is really Martin Luft notation.
Yeah, right. I say that I'm using the lambda notation.
Okay.
Yeah, and another thing that I didn't mention is that, well, those inference rules here, at least in this slide, they're not Frege's. They are just
right,
kind of type theoretical. Okay. They're not Grundgesetze style.
Okay.
And maybe I should have a subscript for the inference rules that are Grundgesetze style and those they're not, but they're not Frege's.
Thanks for clarifying.
Sure. And well, the second point is that you have to abstract open terms. Abstracted open terms are function terms. And again, church function terms, they're closed terms. They're not unsaturated expressions. But a thing that is interesting to note is that, so it's important to stress here, is that we still have a theory of abstraction that it's essentially the same, in a sense that first you have an unsaturated expression, and then you somehow saturate it. And in a sense, in this sense at least, Frege's approach and church, they're the same. But a few authors, there are some authors such as Potts that think that they're essentially, they're fundamentally different, at least in the sense that for Frege, function application must always result in an object, and that for a church, functions are not allowed to be values. So that's an important shift in church conception of abstraction. But I'm not sure how I should agree with Potts here, because well, Frege really anticipates current function, as is well known, because his theory of binary functions really just is a conception of current functions. For Frege, binary functions, they can be partially saturated. So if you have f of x, y, for example, you can either obtain, and you have a closed term a, you can either obtain a unary function f of a, y, or you can obtain another one, f of x, a. And there are two ways in which you can obtain unary functions. So it seems somehow that, well, function application also results in function, at least in this sense. And I was careful here to not to say that Frege had a notion of currying, because and currying, at least type theoretically conceived, when you have a curried function, there is a certain order to it. So if you have a binary function, then you first have to apply this term. And then if you have f of x, y, for example, you first have to apply a, and then you have x, f of a, y. You cannot just have the other way around. You cannot just have a, and you apply, and then you have f of x, a. because there's order to it. But in Frege's conception, there's no order. You can just apply. You can just apply to in the first argument place or in the second one. But again, that was a side note. One thing that is clear so far is that Frege has a syntactic approach to typing. You have a type of saturated entities and a type of unsaturated entities. And this is important here because the identification of saturated entities and objects on one hand, and unsaturated entities and functions on the other hand, is not very obvious. Well, for Frege, at least, it seems that it is obvious, but it's not obvious to everyone. Because, for example, in type theory, in modern type theory, you usually you do not endorse a syntactic approach to typing. The conception of typing is semantic one. It's a semantic one in the sense that if you have a numeral that is supposed to stand for a number, then it is supposed to belong to the natural number type because that's what it means. And if you have a true value, then it's supposed to belong to the Boolean type because, well, that's the meaning of the term. But for Frege, there's no such distinction because there's only a syntactic distinction. And if that's unclear, there's one way we can see Frege's endorsement of this idea. And this way is in his rejection of Russell's early proposal of a theory of types. And as Very already noted very recently, for Frege, this proposal would violate the law of excluded middle. And I think that's it's a somehow strange objection, Frege's objection here. So he says that it seems that you want to prohibit formulas like phi applied to its value range in order to avoid the contradiction. But if you admit a sign for the extension of a concept, a class, as a meaningful proper name, and hence recognize a class as an object, then the class itself must either fall under the concept or not. Tertium non datur. If you recognize the class of square roots of 2, then you cannot evade the question whether this class is square root of 2. But it seems that Frege is missing the point here, because if you prohibit a sentence, P of A, to express a sense, then why should you really care about its reference, since it doesn't have any sense? So for Frege, the idea is that for a sentence to be to qualify to have sense, it seems that it is enough that you have a predicate and a proper name. And then if you have a predicate P and a proper name A, then P of A, it's already supposed to have a sense. At least this is what I get from all of those quotations. So if you have Caesar, for example, a proper name Caesar, and if you have a predicate as a prime number, then Caesar as a prime number must have reference because, well, it has a sense in the language of Grundgesetze, for example. And for Frege, this is not a category mistake, and that's important because for Frege, all the categories that matter, they are syntactically described. They are the only criterion that determines whether or not their category is syntactic ones. So for objects, it is that they are saturated, and for functions, it is the fact that they are not saturated. They are in need of completion. And this is completely different from Carnap's meaningless example of Caesar is end, which for Frege, it would not have a sense, or Frege would not worry that it doesn't have a sense. So it would not violate the law of excluded middle if you just say that, oh, this doesn't have a true value. So he would not worry about it. But for cases such as Caesar is a prime number, he would worry about it because it is a well-formed sentence, so to speak. But what seems to be Russell's idea here is that you just prohibit it for being a well-formed formula at all, so that you don't have to worry about it. So Frege is vacillating here between viewing functions as closed terms of a function type and functions as open terms formed through a hypothetical judgment. At least this is how I see things from the perspective of type theory. And I think this can be seen in a letter to Russell on November 13th, 1904, where Frege here in this letter, he considers a function abstraction device for function terms. So typically, well, he always had such a device for value ranges, right? You have an abstraction operator. But in this letter, he's considering the idea of having such a device for function terms. And it might be confusing here because the notations are very similar. You remember that Frege writes a value range term with a smooth reading notation. But here he's using a rough reading notation. So that's different. So for a function term that he would otherwise write as that which squared equals 1, he would write in a value range like kind of notation. And he here says that this notation, it will lead to the same difficulties as my value range notation, and in addition to a new one. For a range of values supposedly an object, and its name a proper name. But this term here would supposedly be a function name, which would require completion by a sign following it. So this expression applied to the numeral 1, would have the same meaning as 1 squared equals 1, and accordingly, that function applied to like implication would have the same meaning as that term, which, however, would be meaningless. So this notation here would be this term here would be defined only in connection with an argument sign following it, and it would nevertheless be used without one. It would be defined as a function sign and used as a proper name, which would not do. So it seems here, at least, well, that's I think that's up for debate because this is a very, I think that's a vague argument. At least that's it strikes me as a vague argument. But I think what I get from this quotation here is that for Frege, it is possible to use this notation, this function term here, in isolation as an object term because it has no argument places at all. And that's the only reason why you can use it in isolation. While his usual notation, you can use this expression as a proper function term because this expression is in need of completion. So there's an identification here, again, between function terms and open terms and object terms and closed terms. And this would explain why for Frege value ranges, truth values, and numbers, they're all assigned to the type of individuals. Because, well, there's no other possibility. So before I conclude, let me just consider real quick the second interpretation that I was talking about before. And the idea is that, well, what would happen if we just conflate function terms with Roman marks? Obviously, this is not something that Frege would do because there is a subtle distinction between the two of them for Frege. But at least for the sake of this type theoretic analysis that I'm doing, what would happen? Well, first, we would have that the primitive first level function terms of the ideography, they would be primitive open terms. So we'll have all those functions as open terms. And so far, so good. But what about a second level functions? Well, this is where you get stuck because there's no way to extend this interpretation to higher functions. Why? Well, because in type theory, you cannot have an open term that depends on another open term. An open term can only depend on typed variables, on a list of typed variables. And this is what the structure of a hypothetical judgment says. But I think there's a very natural way of bypassing this idea, which is to characterize second level functions as inference rules from open terms to newly closed terms. And at least from this perspective, you can see that Frege's conception of universal quantification and abstraction, they're very similar. So first you have an open term, which is supposedly a function, a Fregean function in his sense. But in here, in my type theoretical analysis, it is an open term in the sense of modern type theory. And so you have, first you have an open term, f of x, that depends on x. And here you have two alternatives. Well, it can either be a quantified sentence or a value range. And I think this is one of the puzzles that was plaguing Frege, maybe, because, well, function terms and Roman marks, they are unsaturated in the same way. But from one, you get a quantified sentence, and from another one, you have a function. And I think that Martin-Lev type theory gives a beautiful answer to this puzzle. And the answer is that, well, you don't have to split through. You don't have to have two different rules. You don't have to separate between one rule that gives us a universally quantified sentence from a open term, and one other rule that gives us a value range from an open term. You could just have one rule that gives us a value range, and under this Curry-Howard isomorphism that says that types and prepositions, they are essentially the same thing. You can have you can also have this universally quantified sentence as a type. So just have one rule instead of two. And I think that's a beautiful way of solving this puzzle, at least if you are a constructivist, because you are giving a functional interpretation to this to the universal quantifier, at least. So this is basically what I wanted to say today. And to conclude, I presented two type theoretical interpretations of Frege's functions. The first one was in terms of closed terms of the function type. And, well, what are its benefits? Well, it is consistent with the hierarchy of types, which is a good thing. But the problem is that it seems to go against Frege's conception of function terms, because function terms, closed terms, they're not exactly the Frege's function terms, which are unsaturated expressions. So this interpretation seems to be unsatisfactory. And the second interpretation that I considered just now was interpretation of function terms as open terms in a hypothetical judgment. And, well, it has a pro that is consistent with the unsaturatedness of Frege's function, which is good. But the bad thing about it is that it cannot accommodate well Frege's hierarchy of types, because, well, first, you cannot even have a reasonable account of second-level functions. You have to use the trick of using inference rules to interpret Frege's second-level functions. And at least I can't see a way of making sense of third-level functions in this way. But in sum, none of those interpretations seems to be close to Frege's views, Frege's type theoretical views. And I think the answer has to be because of his syntactic view of typing, which is very different from the modern type theory perspective. But still, I think that both interpretations seems to show us that there are many interesting ways in which Frege has at least anticipated a few type theoretic ideas. And that's all I wanted to say today. Thank you very much.
Thank you very much, Bruno. So now, as usual, we have some time for questions and comments. Edward?
Oh, I was clapping, but I could answer if other people.
Maybe I should stop sharing.
Good. Thanks very much. That was really interesting. My main observation is near the beginning. If you could say where you say what type theory is. If you have that slide available, I don't have it in front of me, and
yeah, sure.
You had a
go back to it.
link.
I have to share again, but I'll do that in a second.
You had a link to your website, but you found the paper, not the
Oh,
slide.
right. Yeah. The slides they're not available yet. I'm sorry about that. Let me, okay, present now. Window. Okay. Sharing. So we should be able to see it now.
It's coming. It's coming. Okay, so so can you move forward, because where you start talking? Yeah, keep going. One more.
Mm-hmm.
Again, another one. Yeah, there you go. So so that right there, you say type theory is mainly concerned with judgments of type membership. Actually, I think from a historical point of view, that's not really what type theory has been mainly concerned with. It's been type theory is mainly concerned with judgments of type membership only really since, well, I mean, Martin Loof, or you might let's see, what's another option? Well, what's a good example? It's not, because it doesn't occur in Russell's system of types. It doesn't occur in Church's system of types. It doesn't occur in modern.
Right. Yeah. Not explicitly.
Types. Nobody talks about judgment because it's not part of the language they're interested in. They're not interested in making judgments about terms.
Right.
They're part of a type. So I think just it's a little bit too strong to say that that's what type theory is.
I think
you're providing a special perspective from, let's say, possibly Martin Loof's understanding of types and his way of making adding some additional theory to the understanding of types. But strictly speaking, you know, you can do type theory, and moreover, the assumption here is, by taking this Martin Loof perspective, you're assuming that type theory only comes in really one form, functional type theory. Whereas
there's also the
relational type theory, and relational type theory need not follow this, because for one thing, in most formulations of functional type theory that have been attempts to analyze Frege's view, you have two basic types: a type for individuals and a type for truth values. Whereas one of the distinctions, and then you build a language where the notion of a formula comes for free because it's any term of the type of a truth value, and then you simply don't get a term logic; you get a formula logic as well. So and that has many virtues to it that, you know, is not acknowledged in this framework. So, for example, I mean, I think you do accurately reflect Frege's view that, you know, in some sense, you don't need to have a distinguished type for truth value, because really his content stroke, I mean, it's supposed to pick out for you those expressions which are assertable, because he,
in a sense, they're a subtype of the object type.
Judgment content stroke, really. So for example, you could have the vertical stroke and then the letter and the numeral 2, and that would assert something that's the false. That would denote false, because it's 2 is not a judgeable content.
Right.
And many people want to just rule that out and say, look, you know, really, strictly speaking, Frege didn't need that. What he really wanted is he had a special distinguished individual, the true and the false, two types of distinguished individuals, and then his type theory is built on that. So, you know, there's an argument to be made that, you know, a better representation of what he really intended would use a primitive additional base type. Now, and that's, of course, what distinguishes relational type theory, because with the relational type theory, you don't need an additional base type, because if you take a simple base type of I for individuals, and then you let your derived complex types be relations, then when the relation has no arguments, it's the empty type, then you get the propositions for free, because the empty type is the zero place relation.
Interesting.
So there's a whole lot of assumptions going into your. I mean, I like it. It's just that you have it made clear to someone who's
yeah,
coming
I
to
think
this from philosophy.
I think
what all
somehow
the
by
assumptions
modern
are.
type theory, I mean mainstream modern type theory.
Yeah, well,
Yeah.
it's not even mainstream. I mean,
Yeah.
not everybody follows Garten-Luft type theory. I use type theory very differently than Martin to build languages and a formal theory, and other people do too. I think if I look at Williamson's book, I don't think that Williamson uses Martin-Luft type theory to give a type theoretic version of his theory. But anyway, for those who are interested in type theory per se, as opposed to what it helps you do when building a language, then yeah, the people who are interested in extending the notion of type theory so that it becomes a theory about the judgments of type membership, well, then yeah, that's a special version of type theory. Anyway, that was the main observation. And it does have to do with the question of whether you think the content stroke and then the numeral 2 is well formed. In Frege's system, it is, but for most other people, they would say no. That just doesn't make sense. That's not a formula.
And precisely that's because just because Frege endorses a syntactic conception of typing.
Yeah,
this is why it makes sense. This is why you have to decide its truth value.
Right. So other people would get it through typing. He gets it through this content stroke and the interpretation of the content stroke. So anyway, I just thought that was something for you to consider when you.
Yeah. Thank you.
So yeah, good. Otherwise, that was interesting. Oh, there's a paper you might want to look at by Kai Wehmeyer and Peter Schroeder-Heister called Frege's Permutation Argument Revisited, because you make it sound like it's a done deal in section 10 that Frege definitively identified truth values with courses of values. It's just a hypothesis in section 10. He says this is what we could do. This is not officially part of the system, as far as I can tell.
Really?
And I don't. I mean,
well, if that's not really a stipulation in the strong sense, then it seems that his proof of referentiality it doesn't go through anyways because it's inconsistent. But
well, okay, because maybe we need to look at the language of section 10. But I got the impression from some of these other. Hang on one second. Let me look up this paper by.
I think for the suggestion, I still haven't had time to have a look at this paper.
So the opening line of Kai Wehmeyer's paper with Schroeder-Heister is, in section 10 of the Grundgesetze, Frege advances a mathematical argument known as the permutation argument, by means of which he intended to show that an arbitrary value range could be identified with the true. No, does that mean he officially identifies it with the true? I don't know. We'd have to go back and look at Frege.
Yeah, because if he doesn't identify it, then because in section 31 he goes over all the referentiality criterions, right? And one of those are well, he has to look at identity cases, and he also looks at, well, first for identities you have value ranges, for example. You have a value range term here, and on the other side you have an argument letter. And well, if it's in a value range, then the basic law 5 already solves my problem. But if it's a truth value, then my stipulation in section 10 solves the problem.
Well, I mean,
this is just off the top of my head, of course. It's
a reasonable hypothesis that that's what it intends, because, and I'll tell you why. My view is that, look, Frege had this problem with these biconditional things like Hume's principle and directions and shapes because of the Julius Caesar problem, right? How do we know that Julius Caesar isn't identifiable with the number 5 or 5? Because Julius Caesar equals X or 5 equals X, given his definition. How do we know whether the number of planets is identical to Julius Caesar? And it's because he doesn't have an arbitrary definition of when the Julius Caesar or the number of planets is equal to X for arbitrary X. So the same applies to basic law 5. So by collapsing truth values into courses of values, he doesn't have to worry about that anymore, because then look, the variables only range over courses of value. So
yeah, precisely. Yeah, so it doesn't really. Well, I have a paper on 2018 paper in the Notre Dame Journal of Formal Logic, what says that basically the idea is that, well, the persistent version of the Julius-Caesar problem in section 10 of Grundgesetze, first volume, is not really important for Frege because, well, his object letters, they only refer to logical objects, and it's okay if Julius Caesar could be a value range, but it doesn't really matter because for him, value ranges are the paradigmatic case of logical objects. So
I see.
That's fine.
All right. Well, I could see that. It wasn't just clear to me that that was an absolute conclusion that he drew, but just simply showing what he could do. But maybe you're right.
Yeah, I mean, I'm not saying I'm right.
I haven't looked at that in a long time, so anyway, it's an interesting question.
Yeah, that's yeah. Thanks for pointing this out, Ed.
Any other question or comment? Okay, so thank you very much, Bruno. It was a really nice talk.
Thank you. Thanks for the invitation.